Hi, good morning, everybody. So, welcome to Just Get Civil. Welcome to Mission Gate 2021. So, today uh, we are going to start our lecture series. This is the lecture series we are going for the crash course for environmental engineering, and today is the 13th lecture of this series. And myself, Soumyajit Sen. We are dealing with this environmental engineering crash course for Mission Gate 2021. Before going to the subject details, I just want to give you a reminder that if you don't have the Unacademy Learning app in your system, then go to your Play Store, type Unacademy Learning app, and install it. Install it as quickly as possible. Install it, don't be late because it's better to start early the preparation process. Install as quickly as possible Academy Learning app, and you go for GATE and EAC courses, which is actually as you are GATE and EAC aspirants. Go for plus courses where you will get the personalized mentorship program, and you will get the different materials, questionnaires, good set of questionnaires. Will be exposed to the topmost educator courses, and good for subscription. If you are going for the subscription process, then you don't forget to apply the code SEN10 ACN10. Don't forget to apply the code SEN10. It will help you to get directly 10% of the it will help you to get directly 10% of this value, 10% discount to these values. Now we've already started it yesterday, that Evolve for Gate 2022 Civil Batch A, 11:15 a.m. English and Hindi, both the subjects, both the language. If you have not gone for the subscription, do it right now. Never be late for the preparation process. Be early on that part. It will help you to. It will help you, or it can give you an extra edge for the better preparation for the process of your gate paper solving. You're going to get the topmost educators over there, and while putting the subscription of that thing, then don't forget to apply the code send 10. Don't forget to apply the code send 10 ACN10. And today evening 6 p.m. is Unacademy Combat. You need to enroll for free at Combat Live on today 6 p.m. itself. Register now, and to unlock use code CRACKGET. To unlock use code CRACKGET, CRACKGAT. Exciting prizes are there. The questionnaire will be set by the topmost educators, and of course you are going to get the live video lectures. Win exciting prizes, 3-month subscription or equivalent Amazon voucher you are going to win. For rank 4 to 50 rupees 500 Amazon voucher you are going to win. So don't be late. It is a time to get registered in Unacademy Combat. Don't be late. So as we are done with the characteristics of wastewater, we are now entering to the next chapter, which is wastewater treatment. And in wastewater treatment, today we will see two type of treatment techniques. Uh, and the next class we will see two type of treatment techniques. Like this, it will go on in 3 and 4 classes will be over for this. So, treatment of wastewater. Treatment of wastewater is not that easy like the domestic water supply. In domestic water supply, I have told you that we are actually concerned about two type of impurities. One is particle, which will be classified into three different groups, like suspended, colloidal, and your dissolved solid. Another one is this microorganism. Eventually, we have seen that if you are treating a surface water and converting it into domestic water sources, we're actually going for four type of treatment process. What are the four type of treatment process? Plain sedimentation, coagulation flocculation, disinfection, and filtration. So first the sequentially plain sedimentation, coagulation flocculation, then filtration, then disinfection, then you are going to get supply. And the same thing when you're applying for the groundwater treatment, then you are going for this a normal process of what you can say it as normal sedimentation means plain sedimentation coagulation flocculation is not required there. What you are going for, the first we are going for this aeration technique, then we are going for the this water softening process, then we are going for filtration and disinfection and supply. But in case of wastewater treatment, the things are a bit complicated in nature. The wastewater treatment here, first wastewater will go through three types of unit operation. Unit operation means we know that where physical forces are getting applied to remove the pollutant. They are screening, grid chamber, and skimming tank. Screening is nothing but the removal process of large objects. Grid chamber is used to remove the grit particles from water, and skimming tank is used to remove the gaseous particle from water. And finally, the it will go to the primary sedimentation tank. So these four, screening, grid chamber, skimming tank, and primary sedimentation, all are unit operation. These four is the first segment of wastewater treatment, which is called as primary treatment or 1 degree treatment, which is called as primary treatment or 1 degree treatment. On contrary, the first three segments, screening, grid chamber, and skimming tank, the first three, screening, grid chamber, and skimming tank, these three are called as preliminary treatment. So we can say that preliminary treatment plus primary sedimentation will be primary treatment or 1 degree treatment. Now here is a hint that I have told you, if you remember, while dealing with this domestic water supply engineering process, I have told you that there will be four type of settling process generally observed in environmental engineering. First two, type 1 and type 2, we have seen in two type of techniques in the water supply, domestic water supply engineering process. In type 1, we have seen for uh, the process as plain sedimentation or discrete settling. In type 2, in coagulation flocculation process, we have gone for the flocculant settling. In type 3, in the primary sedimentation tank, what you will see in the primary treatment segment, they will go for type 3 or hindered settling process. And then after that, the primary sedimentation, the wastewater will enter to the biological treatment. And all the biological treatment process are generally followed by a secondary sedimentation tank. There is no such difference between the sedimentation tank of primary and secondary. Actually, in the as the position of the sedimentation tank is second, that's why it's secondary sedimentation tank. So this biological treatment and secondary sedimentation tank is called as secondary treatment or 2 degree treatment. And finally, after the secondary sedimentation tank, it will go to disinfection, special treatment, and disposal. This disinfection and special treatment segment is called as tertiary treatment or 3 degree treatment. And the secondary sedimentation tank, which is actually following the biological treatment unit, will undergo the type 4 settling process. So actually, in brief, what I can say that wastewater treatment is classified into three segments. One is primary treatment, another one is secondary treatment, another one is tertiary treatment. Okay. Now, when you're talking about primary treatment, it's nothing but preliminary treatment plus primary sedimentation tank. Preliminary treatment plus primary sedimentation tank. And where in the primary sedimentation tank, type 3 settling or hindered settling will be observed. In the primary sedimentation tank, type 3 settling or hindered settling will be observed. Whereas in the secondary sedimentation tank, which is actually following the biological treatment process, where type 4 settling or zone settling or compression settling will be observed. This thing will be told to you. Okay. Here it will observe the settling of type 4 sedimentation. Here it will observe the settling for type 3 sedimentation, primary and secondary respectively. And there is a term I have used as a special treatment. Actually, special treatment is the process where you are when we are going to deal with the wastewater coming from an industry, because each and every wastewater is having different types of properties. So wastewater coming from industries will have the thing as the industrial wastewater. Now, to treat those industrial wastewater, your special attention is required, because each and every industry will produce unique certain amount of uniqueness in the wastewater. So, to remove the wastewater coming, or to remove the pollutant of the wastewater coming from an industry, they require a special type of treatment, and so require special attention itself. It is not generalized treatment. Okay, and I am giving an example of any tannery industry. There you need to put chromium removal technique. Whereas if you are going for any textile industry, you need to go for the removal of dye or color from the water. So special treatment is actually associated with the industrial wastewater, and as I have told you before, that as we are not concerned about the industrial wastewater, that's why we will actually go for we will not go for the special treatment anyway. Okay, so for our case, we will discuss in details the primary treatment and for the secondary treatment. We will discuss in details the primary treatment and secondary treatment. In primary treatment, in primary treatment or 1 degree treatment, uh, uh, their wastewater will go through certain unit operations like screening, grid chamber, skimming tank, and primary sedimentation. Whereas screening, grid chamber, and skimming tank combined is called as preliminary treatment. Okay. The primary treatment and secondary treatment is nothing but the biological treatment along with the secondary sedimentation process. In secondary sedimentation process, type 4 settling process will be observed. Type 4 settling process will be observed. Okay. Let's have a quickly have a look on this process. কোন ক্লাস নিচ্ছি ক্লাস রেকর্ড করছি একটু পরে কল করছি। So as when so we are not concerned about the tertiary treatment process, we are concerned about primary treatment, secondary treatment, and tertiary treatment. So, but means tertiary treatment we will not go in details, because disinfection we have already seen. So first chapter, chapter A, will be primary treatment. Chapter B and later on will be the biological treatment process, where first we will go to the activated sludge process, then we will go for trickling filter, then we will go for sludge digestion, then we will go for septic tank, oxidation pond. These all are the secondary treatment, means the component of sludge digestion. Sorry, the component of biological treatment. And finally, we go for disposal of sewage effluent. Okay. So in this chapter, in this class, we will discuss with the primary treatment completely, and we'll also go to a segment of activated sludge process. We'll also go to a segment of activated sludge process. Let's go for the primary treatment. What is primary treatment process? Primary treatment process comprises of screening, grid chamber, skimming tank, and primary sedimentation. Screening, grid chamber, and skimming tank, and primary sedimentation. So what is screening? Screening is the first unit operation encountered by wastewater where large floating objects such as water, paper, plastic, cloths, glass bottles, wooden pieces are getting removed. That means that is actually nothing but a sieving process. ये कुछ नहीं है, एक sieving process है. सोच लीजिए आपके हाथ जो है ये एक स्क्रीन है. पानी जब बह रहा है, whatever the bigger size particle which is having higher port size, higher diameter than the port size will get restricted from the flow. It is the first unit operation encountered by wastewater where large floating objects such as waste paper, plastic, cloth, glass bottle, wooden pieces are getting removed. Okay, that is all about the screening process. Now, if they are not removed, then they will cause choking or clogging problem. If they are not removed, then they will cause choking or clogging problem. Now, screens are device provided with uniform size opening. Screens are device provided with uniform size opening. That means if it is a screen, all the opening size will be same. All the opening size will be same. And it is made up of metal rods or bars. Screens are device provided with uniform size opening and it is made up of metal rods or bars. Based on the size of the opening, screens are of three types. Based on the size of the opening, screens are of three types. Core screen greater than 50 mm diameter, medium screen 6 to 50 mm diameter, and fine screen less than 60 mm, 6 mm diameter. So better than more than the means what to say, depending on the size of the opening, screens are of three types. Core screen greater than 50 mm, medium screen 6 to 50 mm, fine screen less than 6 mm diameter. Okay. Going for the design parameter. Suppose n is the number of opening. So if your hand is a screen, so here number of opening is 3, but number of rods is nothing but 4. Okay. If n is the number of opening, n plus 1 will be the number of rods. Clear? The size of the opening is defined as capital S and the diameter of metal rods is defined as phi. Diameter of metal rods is defined as phi. So B equals to there is a width. Try to understand. B equals to ns plus n plus 1 into phi. So B equals to ns plus n plus y in n plus 1 into phi. So that is your B actually. Ns in number of openings plus this one is removed. No, so n plus 1. The n plus 1 is the number of rods into 5. That is also giving you B. Approach velocity VA will be in between 0.6 to 1.2 meter per second. Approach velocity VA will be in between 0.6 to 0.12 meter per second. Cross-sectional area B into H will be equals to Q by VA. Cross-sectional area B into H is equals to Q by V. Depth of screen will vary in between 0.08, 0.8 to 0.11 meter. Depth of screen will vary in between 0.8 to 1.1 meter. Okay, that is the main thing. Just have a look. I'm just coming within a minute. So cross-sectional area B into H will be equals to Q by VA, where H is the depth of screen, will vary in between 0.8 to 1.1 meter. 0.8 to 1.1 meter. The separation velocity, which will be defined as Vs, separation velocity means velocity जिस velocity से ये दूर पे जाएगा, मतलब स्क्रीन से पानी दूर जाएगा, that is defined as Vs. And Vs head loss due to the screening process will be defined as Vs square minus Va square by 2g into 1 by 0.7, where this 1 by 0.7 is called as the screen parameter. As we know that Va is equals to Q by cross sectional area, that is Q by B into H. Now what will be Vs? H depth of screen will be fixed is H, but if B should be B dash. Now the question is the B dash is equals to B? Answer is written here itself that no, B dash is not equals to B, because B dash is Ns. Why B dash is Ns? Because when the water is getting separated from the screen, it is only getting separated from the pores, not from the rods. So only the total depth of this summation of the total depth of pores. Depth means here I am talking about the B. With the pore will be the B dash. So Vs will be equals to Q by N into S into H. Vs is equals to Q by N into S into H. Sometimes screens are provided with some angle theta. The question is why? Why? Because if it is provided with some angle theta, then Vs will be modified Vs, separation velocity will be Q sin theta by NSH. क्यों कहते हैं ऐसे? क्योंकि जब भी ये Q sin theta by NSH हो जाएगा, तब भी ऐसा होगा कि भैया Q मतलब जो Vs का वैल्यू है, मॉडिफाइड Vs है, वो ओरिजिनल Vs से कम होगा. क्यों? क्योंकि जो मॉडिफाइड Vs है वो उसमें आपका साइन थीटा पैरामीटर मल्टीप्लाइड हो रहा है ओरिजिनल Vs के साथ. जब भी ये साइन थीटा पैरामीटर मल्टीप्लाई होगा और थीटा का वेरिएशन है 30 to 60 डिग्री. जब भी ये साइन थीटा पैरामीटर के साथ मल्टीप्लाई होगा और थीटा का वैल्यू 30 to 60 डिग्री होगा, तब क्या होगा? तभी इतना तो समझ में आएगा कि भैया वो जो Vs है, मॉडिफाइड Vs सेटलिंग वेलोसिटी है, वो साइन थीटा का वैल्यू ऑब्वियसली लेस देन 1 है, तो इट विल गेट रेड्यूस्ड. So what is the point to reducing the separation velocity value? To reducing the separation velocity value, the basic point is we need to understand what is separation velocity. Separation velocity is the velocity by which water is getting separated from the stream. If separation velocity is higher, then there is a high chance that the water is taking away lot many particles along with it, which can be restricted if the velocity is lesser. That is why here the velocity is getting reduced to take the separation velocity is getting reduced so that the particles removal from the screen will be less to increase the efficiency of the screen. There is a problem listed. Understood? There is a problem listed. Find the number of spacing and number of bar required for a screen device which is treating 25 mld of raw water. The approach velocity is 1 meter per second. Depth of screen is 0.9 meter. Size of the opening is 25 mm and the dia of metal rod is 10 mm. Also find the head loss through the screen if it is inclined in 60 degrees. Please go to the problem, solve it. Take your time for 1 or 2 minutes, then solve it. Let's see the solution process. Q given as 25 mld, approach velocity 1 meter per second. So cross sectional area will be this Q by VA, that's 0.289 meter square. H is given as 0.9. So B will be 0.321 meter. Let N is the number of opening and N plus 1 is the number of rods. So B is actually equals to NS plus N plus 1 into phi. So N will be equals to, from here, S and phi is given 8.88.9. Number of rods is 9 plus 1, 10. N is the number of opening 9. HLS will be VS square minus VS square by 2G. VS square is Q sin theta by NSH. So HL is coming as 0.0384 meter. Okay, that's it. Now we are going for the next operation is grit chamber. So grit chamber is used to remove grit particle from water. What is grit particle? I will come to the discussion. If these grit particles are not removed, then they will create clogging or clogging problem for further process. Grit particles are of two types, inorganic grit and organic grit. Both inorganic and organic grit are inert and not biodegradable. Both inorganic and organic grit are inert and non-biodegradable. Okay, and the difference is DP inorganic grit, DP will be less than 0.2 mm. Organic grit DP will be greater than 2 mm. G will be greater than 2.65 and organic grit G will be in between 1.05 to 1.1. For inorganic grit, example is sand, glass pieces. For organic grit, example is egg cells, coffee beans, etc. Clear. Now, grit chamber is specially designed rectangular sedimentation tank with high LH to B ratio. So actually, what is grit chamber? It's nothing but a specially designed rectangular sedimentation tank. So every concept of sedimentation tank will be there. The only thing is that it is with high LH to B ratio and having a proportional wear to control the horizontal flow velocity. The VH will vary in between 0.2 to zero point 0.4 meter per second. VH will vary in between 0.2 to zero point 0.4 meter per second. Ideal value of VH will be in between 0.3 meter per second. Why we are doing this? You see, we know efficiency is equals to Vs by V naught into 100 from the plane sedimentation concept. So to increase the efficiency, as settling velocity is not in your hand, to increase the efficiency आपको क्या करना है? Settling this design settling velocity has to be kept low. और V naught को नीचे थोड़ा कम वैल्यू करने के लिए उसको क्या करना है आपको? V naught is what? Q by L into B. Obviously आपको L into B को बढ़ाना है because Q cannot be altered. So यहाँ पे देखिए मैंने दो चीज बोला था कि with high LH to B ratio, देखिए high LH to B ratio. तो high LH to B ratio का LH to B ratio का मतलब क्या है? V naught is getting decreased. इसके सिवाय देखिए L by H is equals to VH by V naught, that you also know, correct? So if H is fixed, Now L is getting increased, इसको अगर आप बहुत ज्यादा कर देते हो और VH को भी अगर फिक्स कर देते हो तो इस मामले में V naught will get reduced. Understood? So what is the final motto? कुछ भी कर रहे हो आपका टारगेट है V naught को घटाना, क्योंकि V naught जितना घटेगा आपका एफिशिएंसी उतना बढ़ेगा. Clear? Have a look once again. Is to be generally vary in between 6:1 to 8:1. Descent time will be in between 1 to 3 minutes. Height of the tank will be in between 2 to 4 meters, and velocity of flow will be in between will be defined by Q into dt. Sorry, Q into dt is volume of tank, and L length of tank will be given by VH into dt, horizontal flow velocity into retention time. It is volume of tank, extremely sorry. It's slip of tank. The settling velocity of grid particle will be estimated by modified Hazen's equation for grid particle. It is estimated by modified Hazen's equation of by for grid particle, where Vs is equals to 60.6 into G minus 1 dp into 50 plus 70 by 100. हमने क्या क्या देखे हैं? हम लोग देखे हैं Hazen's equation for settling velocity in the laminar flow region, Hazen's velocity in the settling flow velocity in the modified Hazen's in the transitional flow region. Now we are observing one that is in the modified Hazen's equation for the grid particle. Is that clear? So have a look to the grid symbol. Now we are going for the next unit operation of this preliminary treatment segment, that is skimming tank. Skimming tank is used to remove the oil and grease particle from wastewater. Skimming tank is used to remove the oil and grease particle from wastewater. If this oil and grease are not removed, so it's actually a special type of removal technique. It cannot be used for all. So if this means it cannot be used for all type of wastewater, it is used only to use the oil and grease particle. If this oil and grease are not removed, then they will interface with other particle present in wastewater. If this oil and grease are not removed, then they will interface with other particle present in wastewater. As the specific gravity of oil is less than water, that is why they cannot be removed by the plain sedimentation process. As the specific gravity of oil is less than water, that's why they cannot be removed by plain sedimentation process, because plain sedimentation process particles are getting removed by the force of the gravity. As the specific gravity is higher than the wastewater, that's why they are getting removed. In skimming tank, hot air will be blown from the bottom of the tank, which will take the oil and grease particle at the top of the water surface as a gas bubble. In skimming tank, hot air will be blown from the bottom of the tank, which will take the oil and grease particle at the top of the water surface as a gas bubble. Now, the surface area of skimming tank. So, actually, here it will be flotation technique will be used. Okay. The surface area of skimming tank will be given by AS, that 0.00622 Q by VR. In skimming tank, hot air will be blown from the bottom and it will take the oil and grease particle at the top of the water surface as a gas bubble. Now, Q is the wastewater flow rates in meter cube per day and VR is the liquid rate velocity in meter per minute. But retention time of the skimming tank will vary in between 3 to 5 minutes. Retention time for skimming tank will vary in between 3 to 5 minutes. The next component of this primary sedimentation tank is from the primary treatment is the after the completion of all the preliminary treatment, the water will be transferred to a sedimentation tank called as primary sedimentation unit for a detention period of 2 to 3 hours. What will happen in this unit? Type 3 settling or hindered settling will be observed. As the particles will be hindered particles, they continuously change their shape and size and they will brought down to the bottom as a hindered particle, type 3 settling. Okay, that is all about the primary sedimentation techniques of this thing. That is all about the primary sedimentation segment. Now, we have quickly finished this because this is not this is the prelude of the wastewater treatment process. We will go for next is go for the activated sludge process. This is biological treatment. It's a major treatment process, that is the biological treatment process. In the biological treatment process, complex will be acted upon by microorganism, which will give you gases, energy, H2O and biomass. The complex will be acted upon by microorganism and these microorganisms are heterotrophic microorganism. What is heterotrophic microorganism? Those microorganisms which cannot produce their own food. If the microorganism can produce their own food, they will be called as autotrophic microorganism. The complex which acted upon by microorganism, they will give gases, energy, H2 and biomass. What is biomass? So complex will be acted upon microorganism will be provided with the simple end product. The question is, what is biomass? Biomass is actually it should be the dead cells of microorganism, but ideally it is the summation of dead cells and living cells. जो बचा हुआ रहता है कुछ कुछ percentage of dead cells should be more, but you can say ideally it should be all dead cells, but it's actually dead cells plus living cells. The complex plus microorganism will be gases, energy, H2 and biomass. Okay. Biomass will be ideally dead cells, but real cases it will be dead cells plus living cells. Now this decomposition process will be of three types: aerobic, anaerobic, and facultative. In aerobic, oxygen presence is must. In anaerobic, oxygen absence is must. And in facultative, any one of these things will happen. In aerobic process, complex will be acted upon by microorganism. In the presence of oxygen, it will produce carbon dioxide, methane, water, energy, and biomass. Whereas in anaerobic process, complex will be acted upon by microorganisms in the presence of carbon dioxide. It will produce methane, ammonia, H2S, energy, and in the aerobic process is fast process. Anaerobic process is very slow process. And we know whatever is fast will be less efficient. Anaerobic process it is slow process, but it is more efficient process. Clear? This aerobic process will be of two types: suspended growth process and attached growth process. This aerobic process will be of two types: suspended growth process and attached growth process. In suspended growth process, you can take an example of this making a tea from tea bag. We are putting the suspension, putting the tea bag in suspension with the hot water, hot milk. This tea leaves will be in suspension with the hot water or hot milk. Then we are going to get the liquor. That is suspended growth process. Example: activated sludge process. In attached growth process, microorganism mass will be attached in the periphery of certain inert media. Microorganism mass will be attached in the periphery of certain inert media, and wastewater will be passed through the inert media. When the wastewater is passing through the inert media, the microorganisms which are getting attached in the periphery of inert media will get exposed to the wastewater, and they will grab the pollutant as their food, and they will discharge pollutant free wastewater. As example, trickling filter, rotating biological contactor, etc. In our syllabus, we will discuss about four type of uh, treatment techniques and one type of post treatment technique. So actually, in brief, we can say that the whole biological treatment process will be of four types: suspended growth aerobic process, attached growth aerobic process, anaerobic process, and facultative process. Suspended growth aerobic process example is activated sludge process that we will discuss. Attached growth aerobic process is trickling filter that we will discuss. Anaerobic process example is septic tank we will discuss. Facultative process will be oxidation ponds that we will discuss. So we are actually going to discuss about four type of treatment techniques, biological treatment techniques: activated sludge process, trickling filter, septic tank, and oxidation. Apart from these four, we will also discuss about sludge digestion process, which is actually a post-treatment process. So total 5 components are there in this biological treatment segment. So have a look. We are going for activated sludge process. Now we are going for activated sludge process. First of all, in activated sludge process, there will be a tank called as aeration tank, where it is the example of suspended growth aerobic process, right? Their microorganism mass will be in suspension. Oxygen will be supplied from outside. Wastewater will be kept. And after a certain point of time, the wastewater will be transferred to the secondary sedimentation tank. After transferring to the secondary sedimentation tank, there the wastewater will get stabilized for certain time, and then from the top we are going to get the cleared water, and from the bottom you are going to get the sludge or biomass. The portion of sludge will be taken out, and of that sludge, certain portion will move to the inlet once again. Why we are doing this, we will tell. The rest of the portion will go for sludge digestion process. That is your activated sludge process. The most कन्वेंशनल बेसिक एक्टिवेटेड स्लज प्रोसेस. ये एक ऐसा प्रोसेस है, अगर इसको डिस्कस करते जाएं तो पूरा एनवायरनमेंट का कोर्स ही खत्म हो जाएगा. खत्म नहीं होगा, क्योंकि लॉट मेनी मॉडिफिकेशन, लॉट मेनी एडिशन, ऑल्टरेशन, लॉट मेनी थिंग्स आर स्टिल evolving. It's still evolving. The secondary sedimentation tank, which is accompanying the biological treatment unit, will show the type 4 settling process or zone settling or compression. क्या है वो भी मैं बताएंगे. ये सिर्फ जोन सेटलिंग और कंप्रेशन सेटलिंग सिर्फ और सिर्फ एक्टिवेटेड स्लज का कहानी नहीं है. इस जो भी बायोलॉजिकल ट्रीटमेंट प्रोसेस को अकम्पनी कर रहा है आपका सेडिमेंटेशन टैंक, देयर विल बी द सेम थिंग. ओके. अब पहला तो है कि इसका नाम क्यों है एक्टिवेटेड स्लज. तो व्हाट इज बायोमास? यू नीड टू अंडरस्टैंड व्हाट इज बायोमास. बायोमास क्या है? बायोमास इज नथिंग बट डेड सेल्स प्लस लिविंग सेल्स. रियल केसेस. So what is the fate, ultimate fate of biomass? You are going to put it into the sludge digestion unit. The point is, if you are putting the whole biomass in sludge digestion unit, that biomass is containing उसमें कुछ living cells भी तो हैं. And who are the living cells? Those living cells are nothing but the soldier for the decomposition process in the wastewater. Those living cells are nothing but the soldiers for the decomposition process in the wastewater. The soldier of the decomposition process in the wastewater, those living cells are nothing but the soldiers. Why? Because they are nothing but the fighter against the pollutant of the wastewater. Pollutant are actually there for you, we, us, but we don't have the capacity to deal with that. We are actually taking the help of microorganism. So they are nothing but the soldier to the in the battlefield. So what you want to give? You want to give a second chance to the living cells. If you want to give a second chance to the living cells, why? Because then if you are giving second chance, then there is a high chance they will decompose. A single living cell will decompose more pollutant, which is actually profitable to us. On the view of this segment, a certain portion of sludge is reactivated once again. A certain portion of sludge is getting reactivated once again, which is called as, that's why it is the process is called as activated sludge process. That's why the process is called as activated sludge process. A certain portion of sludge is reactivated once again. That's why it is called as activated sludge process. What is written? A portion of sludge or biomass, dead cells plus living cells, again put into the aeration tank. because we can't release all the sludge as they contain living cells also, which are important for us. As certain portion of sludge is reactivated, that's why it is called as activated sludge process. It is called as activated sludge process. Now, in the secondary sedimentation tank, this biomass will be in zone, एक पर्टिकुलर जोन पे रहते हैं. कभी कभार आप देखेंगे कि कोई एक मटेरियल है, कोई एक बॉल, जनरली स्टम्पर बॉल, अगर आप पानी में फेंकते हो तो थोड़ा बहुत ऐसे फ्लोट कभी नीचे जाता है, जाने का कोशिश करता है. इफ यू पुट एक्स्ट्रा प्रेशर इट विल गो सेटल डाउन like this biomass will be in zone. Certain compressive force will enhance their sedimentation process, and compressive force will enhance the sedimentation process. That's why this is called as zone settling or compression settling. That's why this is called as zone settling or compression settling. As the biomass will be in zone and certain compressive force will enhance their sedimentation process. That's why it is called as zone settling or compression settling. Zone settling or compression settling. Now, one thing I should tell you, the way I am going to deal with this activated sludge process, you please deal with in that manner only. The notation, the everything you remember in that manner, then only this gate and IS segment will be easier to understand, easier to execute for your problem. Even you understand the notation also. Remember the notation also. If QR is this, then QR is this. Don't represent it as SR or VR or LR or anything. Represent it as QR. First here the schematic is drawn. First I will explain all these parameters. Then I will go for the design parameters of activated sludge process. Before going to that, have a look to this. Now see, there's a diagram. So Q YI V X Q E X E Y E Q U X U Q W X U Q R X U. Lot many things are there. Let's explain it. Q is the wastewater flow rate. It's YI. YI is influent BOD concentration in milligram per liter. YI is the influent BOD concentration in milligram per liter. Then it's V. V is the volume of the tank. V is the volume of the tank. And then it's X. X is initial concentration of microorganism kept in the system. X is initial concentration of microorganism kept in the system, and it's also called as C, Melis's concentration, because this is nothing but the suspended solid mass and it is mixed with water. That's why it's called as mixed liquor suspended solid. It's also called as MLSS concentration, mixed liquor suspended solid concentration. QE is the effluent water flow rate. QE is the effluent water flow rate, and YE, obviously as it is not 100% efficient, YE will be the this effluent water POD. What is XE? Certain portion of microorganism will be there, maybe very less or maybe it's zero, but there is a chance that you can get one or two or very few, but you will get microorganism with the effluent wastewater. It's called. So XE is the effluent water microorganism concentration. Okay. Now from the bottom part of the sedimentation tank, you will take out the underwater. QU is the underwater flow rate. QU is the underwater flow rate. QU is the underwater flow rate, and the underwater solid concentration is provided by XU. Underwater solid concentration is provided by XU. Okay. A portion of sludge will get recycled in the tank once again. It will be recycled water flow rate QR, and the rest of the portion will be wasted to go to the sludge direction. It will be QW. Okay. And what is XU? Is the biomass concentration. XU is actually the summation of living cells plus dead cells. And generally, the dead cells of microorganism are volatile in nature. That's why XU is called as MLVSS concentration. XU is called as MLVSS concentration. Mixed liquor volatile suspended solid concentration. Have a look. These are we have already discussed. Now we are going for the design parameters. Going for the design parameter. First design parameter is F by M ratio. Food to microorganism ratio is the first design parameter. What is F by M ratio? It is the mass of food applied to the reactor to the mass of microorganism present initially. F by M is mass of food applied to the reactor to the mass of microorganism present initially. मैंने आपको एक चीज बहुत ढंग से बता दिया था कि भैया जब याद रखेंगे नोटेशन के साथ और यूनिट के साथ, क्योंकि यूनिट के साथ अगर आप याद रखेंगे तो ऐसा है कि वो जो कहानी जो आएगा उसमें डायरेक्टली यू विल गेट द यूनिट ओवर देयर. इनके साथ अगर आप याद रखेंगे डायरेक्टली यू विल गेट द यूनिट ओवर देयर. कोई दिक्कत नहीं होगा. याद रखना कि हाँ ये पैरामीटर के लिए ये यूनिट था. अगर ये सब डायरेक्टली आप बैठा देंगे तो फाइनल कन्वर्शन में कुछ दिक्कत नहीं होगा. So that is the way to deal with this process. So F by M will be QYI by Vx, which will be Q in meter cube per day, YI in milligram per liter, V is meter cube, and X is in milligram per liter. So F by M के लिए आंखें बंद करके जो भी यूनिट में दिया हुआ है Q आपको लेना है मीटर क्यूब पर डे में, yi आपको मिलीग्राम पर लीटर में, x भी मिलीग्राम पर लीटर में, and v is the meter cube. So mass of food applied to the reactor is q into yi, and mass of microorganism volume into concentration is vx. So qyi by vx will be the f by m ratio in day inverse. Ideal value of f by m will be in between 0.2 to 0.4 day inverse. Ideal value of f by m will be 0.2 to 0.4 day inverse. That is the f by m ratio. f by m ratio अगर बहुत घट गया मतलब क्या है कि फूड कम है तो आप वेस्ट वाटर फ्लो ज्यादा करेंगे. अगर f by m ratio बहुत ज्यादा बढ़ गया तो माइक्रोऑर्गेनिज्म विल बी केप्ट मोर और फूड विल बी अप्लाइड लेस. Okay, that is the significance. That is f by m ratio. Second one. Second one is BOD loading rate or organic loading rate or volumetric loading rate. VL, defined by VL, it is given as mass of food applied per day to the volume of the reactor. Mass of food applied per day to the volume of the reactor. So mass of food applied per day is Q into Yi by V. Now here VL जब होगा, जब F by M होगा क्या था Q का यूनिट? मीटर क्यूब पर डे. here क्या होगा? MLD. MLD into मिलीग्राम पर लीटर by मीटर क्यूब. MLD into मिलीग्राम पर लीटर हम लोग पहले ही देख चुके हैं, इट्स kg per day. Correct or not? If you don't remember, then I'm just writing here. ml into milligram per liter will be kg per day. So Q into Yi is ml into milligram per liter by meter cube. So it will be actually kg per day meter cube. Ideal value will be 0.3 to 0.6 kg per day meter cube. Ideal value will be 0.3 to 0.6 kg per day meter cube. Okay. So for F by M, your Q will be in meter cube per day. Then what will happen? You will be safe enough for the unit conversion thing. Understood? Third parameter is BOD removal efficiency. These are the basic one. Efficiency is Yi minus Ye by Yi into 100. Generally, BOD removal efficiency will be in between. It's written here 85 to 90%, but it will be in the upper limit. It will be around 90 to 92%. Then we are going for detention time. Detention time will be defined by V by Q. But detention time will vary in between 4 to 8 hours. Detention time will vary in between 4 to 8 hours. Next one is mean cell residence time, MCRT, or sludge or theta c. Next one is mean cell residence time, or sludge or theta c. Now, actually defined as a theoretical average time for which microorganism is staying in the system. It is a theoretical average time for which microorganism is staying in the system. But theta c is defined by the equation mass of microorganism present initially to the mass of microorganism wasted per day in days. Mass of microorganism present initially is Vx. The mass of microorganism wasted per day, it will be what? Try to understand from this figure. This is one particular segment where mass of microorganism is wasted per day, we can say. And is that the only? No. This one is another one. Why? Because this microorganism, XC microorganism, if there is any living with the effluent, will not get a chance to get recycled. Whatever is recycled is recycled. They and this will not get a chance to get recycled. That's why they are getting wasted. So actually QWXU into QE plus QEXE. Is that clear? Sixth one is sludge volume index. It is an experimental parameter. You need to understand it carefully. It is an experimental parameter, sludge volume index. It is an experimental parameter, sludge volume index, and generally it will not be found in the tank itself. You have to experiment it. क्या है? आप एक मेजरिंग सिलेंडर लोगे जिसका वॉल्यूम है 1000 ml, दैट मींस 1 लीटर का मेजरिंग सिलेंडर, जहां पे जो माइक्रोऑर्गेनिज्म आप डाले हो जो कंसंट्रेशन में उसमें डाल दोगे, सपोज x ग्राम ऑफ माइक्रोऑर्गेनिज्म यू आर कीपिंग, उसके बाद आप इसको अच्छे तरीके से मिक्स करोगे और आधे घंटे के लिए छोड़ दोगे. As the microorganism mass are actually suspended solids, that's why what will happen, they will get sedimented in the bottom. They will get sedimented in the bottom. Okay. After 30 minutes settlement, what will happen? The microorganism mass will get settled down in the bottom and they will occupy y ml of volume. Let it be. So what is SVI? SVI is volume occupied after 30 minutes stabilization in ml and the mass of microorganism taken in gram. SVI is volume occupied after 30 minutes stabilization in ml and mass of microorganism taken in gram, where SVI is equals to y by x ml per gram. SVI will equals to y by x ml per gram. Understood? And what is the main requirement of SVI? SVI will define what will be the amount of sludge to be recycled. The ideal value of SVI will vary in between 50 to 150 ml per gram. Ideal value of SVI will vary in between 50 to 150 ml per gram. Or SVI will define the amount of sludge to be recycled. Here. Okay. Now, how it is defining recycling process? Suppose there is a young microorganism. Here it is denoted this segment. One young microorganism is there. of mass X. When same microorganism getting old, this fluffiness will be there. For human being, fluffiness can be there in the human body at any age. But for microorganism, fluffiness will be there when they grow old and about to die. Mass will be same. तो पहले केस में अगर इस केस में अगर SVI 1 होता है ये माइक्रोऑर्गेनिज्म को लेके सोचे कि Y1 वॉल्यूम ऑक्युपाई किया है दिस इज SVI 2 में Y2 by X. So both for when you are comparing these two SVI 1 and SVI 2 of as Y2 is greater than Y1 or SVI 2 is greater than SVI 1. The higher value of micro SVI will defines what? Higher value of SVI is defining that old microorganisms are more in the system. So if old microorganisms are more in the system, what is the point of recycling? क्योंकि जो मरने ही वाले हैं उसको दोबारा एक चांस देके फायदा ही क्या है? So when old microorganisms are higher in the system, recycling will be less and reactivation will be less. When the old value of microorganism is higher, then obviously we need to go for, so higher SVI will go for recycling less, reactivation will be less. Recycling less, reactivation less means recycling concentration XU will be also less. Yes or no? Recycling concentration XU will be also less. So if XU is less, that means SVI is inversely proportional to XU. XU is in milligram per liter. 1 by XU is liter per milligram. So from here it is 10 to the 6 milliliter per gram, which is the SVI unit. So we have written that SVI is equals to 10 to the power 6 by XU. Is that clear? Now, term is recycling ratio R, which is defined by QR by Q. Mathematically, R is X by XU minus X, or X by XU is 10 to the 6 by SVI minus X. Generally, R value vary in between 0.25 to 0.5. Okay. And a special case of MCRT, mean cell residence time, that we have we need to discuss, that if Q is not given, what was the equation? If you remember, that MCRT equation is this Vx by QWXU plus QE into XE. If QE is not given, then we need to take the secondary sedimentation tank where inflow will be equals to outflow. And what is inflow for secondary sedimentation tank? We are taking the secondary sedimentation tank as the control volume. Inflow is Q plus QR, and here it's QE, QU. So Q plus QR is equals to QE plus QU. There Q plus QR is equals to QE plus QR plus QW, that is QU. QR cancels, is QE is equals to Q minus QW. Theta C is equals to Vx by QWXU plus Q minus QW into XC. Theta C is equals to Vx by QWXU plus Q minus QW into XE. Okay. Now we'll solve one question. Put that. Just go to the process once again. There's a schematic of ASP. This is the schematic explanations. F by M ratio. QYI by Vx, where Q will be meter cube per day. Yi and X will be in milligram per liter and V will be in meter cube. F by M unit is day inverse. BOD loading rate or organic loading rate or VL. MCRT. SVI. recycling ratio, special case of MCRT, we're going for a problem, show you the glimpses of what type of problem you can expect. A completely mixed activated sludge is used to treat wastewater flow of 1 mld having a BOD 5 of 200 milligram per liter. So till now in the first sentence, whatever information we have uh, received, let me write it down. Q is 1 mld. What is YI? 100 milligram per liter. The microorganism concentration initially is 2000 milligram per liter and leaving with effluent is 50 milligram per liter. Okay. So YI is 200 milligram per liter. For information provided, microorganism present initially is 2000 milligram per liter. Removed from the effluent is 50 milligram per liter. Volume 200 meter cube. Asking detention time. Okay. 100 meter cube. Now first question they are asking detention time. What is detention time? V by Q. What is V? 200 meter cube. So 200 into 10 to the power 3 liter by 1 into 10 to the power 6 liter per day. And cancel it will be in days. Or it is it's actually 0.2 days. This is equals to 0.2 into 24, 4.8 hours. Second part of the question is, what is the average time for which microorganism is staying in the system? Average time for which microorganism is staying in the system is nothing but the theta C. What is theta C formula? Vx by theta C formula is Vx by Qw xu plus Qe xc. Vx by Qw xu plus Qe xc. Okay. So here QE value is not given. From this equation you can say that QE value is not given. So it will be Vx by Qw xu plus Q minus Qw xc. So V is there, X is there, XU is not given, QW is not given. How to solve? See, you need to check statement. Completely mixed. Completely mixed means what? Whatever is the sludge, this is your sedimentation tank. What is going to the secondary sedimentation unit? Effluent. Whatever sludge you are taking out is getting recycled. So nothing is there. So QW is 0. Why? As completely mixed. Vx by Q into Xe. V is 200 meter cube. So 200 into 10 to the power 3 liter, X is 2000 milligram per liter. So what is milligram by Q 1 mld 1 into 10 to the power 6 Xc 50. Final answer will be 8 days. Clear? That is a solution of this question. 8 days. Okay. Now we are going for certain special cases of activated sludge process. We are going for certain special cases of activated sludge process. What are the cases? Normally, if it is the conventional activated sludge process where Q is provided and it is oxygen, effluent oxygen is constant. So if you draw a plot of oxygen supply and consumption with time, you will see oxygen is supplied constantly, that is oxygen supply, and this is oxygen consumption line, because when time increases, the amount of biodegradable organic matter decreases. The concentration of amount of biodegradable organic matter decreases. Eventually, oxygen consumption will also get decreased. Correct. So there is a huge gap will be. To remove this gap, four type of things is modifications will be there: tapered aeration, stepped aeration, extended aeration, and contact stabilization. First one and two is the tapered and stepped aeration will be optimize the oxygen supply. The 3 and 4 extended aeration and contact stabilization will be used to increase the performance. Tapered aeration, what will happen? The whole oxygen supply will not be done once. It will be done in 3 segments. 60% of the oxygen will be done first, then 30%, then 10%. So then obviously there will be oxygen supply, then decrease, then again oxygen is getting supplied, then it will be the oxygen supply. So your gap will get reduced. That is for the tapered aeration process. In stepped aeration, here oxygen will be supplied constantly, but the loading, organic loading will be done in different points. Not all the organic loading will be done in once. So that is the first case. Again, Q is applied, again Q value is increased, again it is getting decreased, again Q is applied, it will be happen. That is called as the stepped aeration. Okay, that is called as stepped aeration. Now, extended aeration. Extended aeration technique, no artificial oxygen supply is made. No artificial oxygen supply is made. The main feature of extended aeration is high retention time, low F by M ratio. Retention time will vary in between 18 to 24 hours, very high. F by M ratio will be 0.05 to 0.1 day inverse. That is one process. And the reactor which follows the extended aeration technique is called as oxidation ditch. It's called as oxidation ditch. Finally, is contact stabilization. In contact stabilization, it is to enhance the performance. Nothing else is there. The recycled sludge before putting into the inlet or of the aeration tank, it is getting aerated in another tank, which is called as contact stabilization unit. That is called as contact stabilization. Okay. ऑपरेशनल प्रॉब्लम एक तो है राइजिंग ऑफ स्लज. स्लज का मतलब है नॉर्मली हम जानते हैं कि लिविंग सेल प्लस डेड सेल. Rising of sludge means where living cells is more than dead cells. Then a sludge will float. Then it will be called as rising of sludge. Remedies, obviously you need to reduce the Q value or you need to recycle more sludges. Just the reduction and chlorination, also the remedies. Bulking of sludge, if dead cells are more than living cells, then SBI greater than 150, oxygen you require to put more and add the nutrient that is there. So have a look of this process of this problem first and the others. The solution. The special cases of ASP. Well, so that's the end of activated sludge process. So just reminder that don't forget, already started the batch for civil engineering, batch A, and in English and Hindi both, 11:15 a.m. So you can go for the batch. Don't be late. If you start as early as possible, it will be fruitful to you, profitable to you people. And today 6 p.m. will be. And first of all, if you are subscribing it, don't forget to use this code today. Today, if you use this, you are going to get the direct 10% of discounts. Unacademy Combat is there. Next Combat goes live on December 29, 6 p.m. Register now to unlock. Use the code CrackGet. Exciting prizes are there. Rank 1 to 3, you will get 3 month subscription. Rank 4 to 50, you will get rupees 500 Amazon voucher. Hey, thanks a lot. Thank you for this session. We'll meet tomorrow for trickling filter and others biological treatment.